What is the ideal gas law's role in isobaric expansion? Imagine a balloon slowly inflating as you heat it up. The gas inside expands, but the pressure stays the same. How does that happen? That's where the ideal gas law comes into play. The law is written as P times V equals N times R times T here. P is pressure, V is volume, N is the number of moles of gas, R is the universal gas constant, and T is temperature in Kelvin. In an isobaric process, the pressure P remains constant. So, if you increase the temperature T, the volume V must also increase to keep the equation balanced. This is called Charles's law, which states that volume and temperature are directly proportional when pressure is steady. Mathematically, it's V divided by T equals a constant. Or, rearranged, V equals NR divided by P times T. Since P and NR are constant during this process, volume depends directly on temperature. What does this mean practically? If you heat a gas at constant pressure, its volume grows proportionally with the rise in temperature. Conversely, cooling the gas causes its volume to shrink. This relationship helps us predict how gases behave when heated or cooled in many real-world situations. For example, in engines or heating systems, gases expand or contract depending on temperature changes, and the ideal gas law helps us understand and calculate those changes precisely. When a gas expands at constant pressure, it does work on its surroundings. The work is calculated by multiplying pressure by the change in volume. As the gas expands, it absorbs heat to increase its internal energy, and to do this work, the heat added at constant pressure can be found using the molar heat capacity at constant pressure, which tells us how much heat is needed to raise the temperature of 1 mole of gas by 1 Kelvin. Understanding the ideal gas law's role in isobaric expansion helps us see how gases respond to heating in many devices and natural processes. For example, when air inside a piston heats up, it expands and pushes the piston outward. The law gives us the tools to predict exactly how much the volume will change with temperature. It also explains why gases are so useful in engines, refrigerators, and even weather systems. In essence, the ideal gas law is the key to understanding how gases grow or shrink when heated or cooled at constant pressure. It provides a straightforward way to connect temperature and volume, making it easier to analyze and design systems that rely on gas behavior.